Okay, we're starting off today with just some basic systems of linear equations. So hopefully this first part should be a review for you. As a reminder for you, if you just had two linear equations, right, the only options are there's no solution, which we call that inconsistent. This vocab will start to become important. Or if something has a solution, we call it consistent. If there's one solution, they're independent, right? Lines are not dependent on each other, they're individual. Or there's infinite solutions, we call those dependent, right? Because they literally end up being the same line. So let's go ahead and start with these first ones, graph the systems of equations and identify the solutions. Okay, I know a lot of you like solving for y, so you're welcome to go ahead and put this into y equals mx plus b form if you want. So I'll do that for this first one, and I'll kind of show you a trick for the second one. So you've got 2x, right? 2x minus y equals 1. If you want to solve that for y, maybe you'd subtract 2x on both sides, right? So you get negative y equals 1 minus 2x, divided by negative 1, y equals a positive 2x minus 1. So you're like, okay, I start at negative 1, I go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, and you connect the points, right? Maybe I should just for kicks go down 2, left 1, down 2, left 1. Okay. On this next one, you're totally welcome to solve it for y again. This one's even actually easier to solve for y. However, as a little trick for you, since some of you will continue on to do math, an easy way to think about all you need to graph a linear equation is 2 points. So if you plug in 0 for x, the y-intercept here, when you plug in 0, you get y equals 5. Whereas if I plug in 0 for x, 0 for y, you'd have negative 4x equals 5. So x equals negative 5/4 is another point. I will say that one did not end up being as nice as I think. So maybe it's better to solve for y, add 4x to both sides, so y equals 4x plus 5. So you start at 5, right? You go up 4 over 1, but that doesn't cross. You also go down 4 left 1, down 4 left 1, down 4 left 1. And you get I didn't mess it up. So down 4 left 1, down 4 left 1, down 4 left 1. Okay, there we go. So here, the solution actually is at the very kind of almost edge of our graph. It's this point here. So negative 3, negative 7 is the solution. And since it does cross, there's a solution, we call it consistent. Since they're two separate lines, we call it independent. Okay, on this next one, okay, that first one, okay, we know what we're doing here. We're like, okay, negative 3, and then I'm going up 1, right 1, up 1, right 1, a slope of 1. I could also go down 1, left 1 if I wanted, right? When you look at that other equation, you're like, well, what's that? You should know from our last unit studying conics, right, what that is? This is saying, hey, it's a circle, right? And it's saying your radius is equal to the square root of 9, so it's equal to 3. Where's the center at? Since there's nothing with the x's and y's, the center's at 0, 0. So you're saying, okay, well, we start at 0, 0, and I go up 3, sorry, right 3, left, up 3, left 3, down 3. So this is my circle. In this case, there are two solutions. So the two solutions are 3, 0, and 0, negative 3. We still call this solution consistent since there is solutions. I won't stress as much about the independent dependent here in this case, though. I believe you'd call it independent since they're separate lines. Okay. On this next one, I did make it a little tricky, but I really wanted to review conics with you, so I think that it was a good call here. So let's take a look at this first one. We've got 4x squared plus 9y squared equals 36. This is not in the format of a conic we're used to. I'm going to tell you right now, it is not a circle because there's not the same number up front. So I want to set it equal to 1, and we'll decide, is it a hyperbola or is it an ellipse? So as you simplify those fractions, you'd have x squared over 9 plus y squared over 4 equals 1. The fact that this is plus means that it is an ellipse. So this ellipse has a center of 0, 0. In the x direction, we're going the square root of 9, which is 3. And in the y direction, we're going the square root of 4, which is 2 on both sides. So your circle looks like that. Okay, now let us consider the next one. Notice it looks almost identical to the previous one. The only difference is this time I've got a subtraction in the middle. Once again, definitely can't be a circle because it's not plus. Because it's minus, you should recognize it as a hyperbola, but if you don't, think about it. Well, I gotta set it equal to 1. So I divide everything by 36, and you get x squared over 9 minus y squared over 4 equals 1. So in this case, center is still at 0, 0. We are going out 3 on both sides. And in this case, our box is kind of that up 2, right? This is our box. So our asymptotes are going to have to be the diagonals through that, right? And your actual hyperbola looks like, actually let me draw it slightly wider so you can see it a little clearer, is this, right on both sides. Remember, it is hugging the x because x came first. So I think about it, hugging the x-axis. Okay, so now we're talking about, well, what are the solutions? Well, these cross at 2 different points, the 2 points there, at 3, 0, and at negative 3, 0. Okay. Here, this should be a review for you. We're going to talk about substitution and elimination. So, let's use both substitution and elimination to solve this system. So let's start with substitution. So remember with substitution, you have the idea that x or y equals something, and we're going to plug it into the other equation. In this case, you may notice that I have an x all alone in that top one. So let me solve it for x. So I'm going to add 2y to both sides. So I get x equals 2y plus 3. Now that I've got that, I'm going to take what x is equal to, which is 2y plus 3, and I'm going to plug it into the other equation for x, such that I have that second equation all in terms of just y. So I'm going to have negative 3 times 2y plus 3. Always use parentheses, otherwise you'll forget to distribute, plus 6y equals a negative 9. Distribute the negative 3, so you get negative 6y minus 9 plus 6y equals a negative 9. You get negative 9 equals negative 9. Since that is a true statement, what does that mean? It means that there is infinite solutions. Since it's infinite, we say that it is consistent. But since they literally end up being the same line, we call them dependent. Okay, what I do with elimination, I should get the same solution, but slightly different method, right? So let's look at elimination now. So the idea behind elimination is we're getting rid of one variable, x or y, by multiplying one equation by some number. I always think about adding them, so I usually look and I'm like, okay, well, x is not too bad. I just got a 1 and negative 3, or I've got negative 2 and negative 6. So either one really works here, but let's look at the x's for a minute. So if you look at the x's, you're saying, what can I multiply this top x by, such that it will cancel out with a negative 3? So a positive 3 times that will cancel out when we add them. So we get 3x minus 6y equals 9. Now we're going to add those two equations together. So notice this top equation and the third equation are exactly the same. We just multiplied by some number. So as we do that, we end up with 0 plus 0 equals 0. So 0 does equal 0, so that means, once again, hey, that we have infinite solutions, right? And it makes sense, since it was the same problem, we should get the same answer. Okay, on these next two, it's up to you what method you want to use. So you're going to substitution or elimination, but then decide, hey, independent, dependent, consistent, inconsistent, depending on if it has a solution or not. Okay, on this first one, I could try elimination, but notice I've got x squared and I just have an x. I've got a y squared, I just have a y. So elimination probably won't work out for you here because the y squared and y don't cancel. Those are not like terms. However, I could take this second equation and set y equal, add 2x to both sides, so to 2x. If I've got that, I can then use substitution here, right? So I'm going to have x squared plus 2x squared equals 5. So x squared, when I square 2, I get 4x squared equals 5. Add that together, I get 5x squared equals 5. X squared divided both sides by 5 equals 1. So x does equal, and you take the square root, you do need two different answers here, plus or minus 1. The only thing you have to do now is go back and plug that in. It doesn't matter which of those three equations on top you plug it into. I'd probably plug it into that bottom one, y equals 2 times 1, and y equals 2 times negative 1. So I get positive 2 and a negative 2. So the solution here is at x is a positive 1, and y is a positive 2, or x is a negative 1 and negative 2. This makes sense. You've got a circle once again and then some line, so it could have two solutions. We call these consistent, right? And they're independent, right? They're separate. They're not the same line. Okay. On this next one, you've got some choices, right? I do have a x in there, so I could set it x equal to something. I could plug it into the second one. But be aware, if you do that, I think you are going to end up with like y to the 4th and then y squared and then a constant, which is just fine. We know how to do u substitution. We can handle that, right? But an easier thing that you may recognize in this case is that, hey, if we look here, these both actually have a y squared this time. So this time I could use elimination, right? And we're saying to ourselves, what can I multiply? In this case, I'd probably multiply the top one by something, right? Because I've got a 2 and a 4. What can I multiply that 2 by such that it will cancel out with 4? So 2 multiplied by a negative 2 gives me negative 4, which will cancel out with 4. So then when we write that top equation, I would have negative 2x minus 4y squared equals a negative 4. I'm going to add these bottom two equations together. I'd have x squared minus 2x. This cancels and gives me 0. And then 4 minus 4 is 0. Make sure you write that 0. This is not saying that there's no solutions, that these things are not equal. This is actually something that you can factor. If you've got two terms there on the left, look for GCF. You've got x minus 2 equals 0. So this first part, if there's just an x up front, means x equals 0. X minus 2 means x equals a positive 2. So now it doesn't matter which equation, but choose an equation to plug it back into. We now need to find the y values. So let's say we use the top one. 0 plus 2y squared equals 2. Divide both sides by 2, y squared equals 1. Y equals plus or minus 1. Okay, let's look at the next one. So we'd have 0 plus 2y squared. 2 plus 2y squared equals 2. Subtract 2 from both sides. Y squared equals 0. Divide by 2. Y squared equals 0. Take the square root, and you get y equals 0. Plus and minus 0 is not a real thing, so just 0. So here you have 0. When you get 0, we got a positive 1 and a negative 1. So that's going to be two different answers. And then we also have, when x is 2, we get y is 0. So this one had 3 solutions. Once again, they are consistent, meaning there is a solution. And it is independent. In this case, just so if you want to think about it visually, we had a parabola as the top one, and then we had an ellipse as the bottom. So while this may not be exactly what it looks like, if you've got a parabola and ellipse, it is possible.